Hi everyone, I'm John Marek, Large Wheel Loader Product Application Specialist. Thanks for your interest in how CAT large wheel loaders can help your success and lower your cost per ton. Let's start with the 994K, and then I'll also be introducing a brand new large wheel loader model that will be available soon. So first of all, looking at the top of this slide, I've got a search icon shown there for you to run an internet search on a CAT publication, PEDJ 0482. So what this will get you is the content that's in the next few slides for your future reference. So I'll start with a frequently asked question over the last year, and the question revolves around having one machine with multiple rated payloads. And the answer to that question revolves around asset utilization. We have the 994K sometimes operating in a low to moderate digging resistance and sometimes operating in a moderate to high digging resistance. And so in those two different applications, the machine, in order to be fully utilized in a lower digging resistance application, it entirely has the capability and the stability to, in that scenario, run a larger bucket and a higher payload. And so the theme revolves around fully utilizing the machine in two different ways, depending on your application. So let's see why this is important. Getting into a little bit of the math. So this isn't a math lesson, but if we look at what's going on here, and we want to try to find out what's our production of our wheel loader going to be, the first question that would come up here is, looking at these equations, where's the wheel loader payload? And the answer is, looking at this production scenario number one, the target truck payload divided by the passes per truck is the wheel loader payload. And the key point there is that if your wheel loader payload isn't a perfect match to your truck, and it's not considering this target truck payload divided by the passes that you actually can make, and you end up with a half pass, for example, you're not actually going to be able to utilize the full capability of the machine. So the key here is we have to look at the truck first, figure out how many passes we can size the bucket for, and once you've done that, then you can be off. Move on to a successful match between the wheel loader and the truck. So I'll show two examples. First, we'll look at the smaller end of the trucks that a 994K can load a CAT 785. And so let's look at the exact pass match, which is the second row on this table, versus the rated payload, which is shown on the bottom for the different configurations. And the key is they're not always going to automatically be lined up. So the trick is, let's say in this example, you want to do a 4-pass match into a 785. Your productivity lines up with the range that you would get for passing. Then the payload that you need nominally is 34 metric tons. The rated payload in that configuration in the moderate to high digging resistance application is 40.8. So you can see that the rated payload is a little higher than you need. And the key is going back to that math on the last slide. Now we want to configure the bucket pretty close to that 34 metric ton target, maybe a little bit higher. But if the bucket's bigger than it needs to be and you can't get that pass from 4 down to 3, you're actually not going to gain any productivity. So let's go then to that 3-pass match scenario. So looking at that situation, what we'd need is 45.4 metric tons or 50 US tons in order to 3-pass into that CAT 785 and get that higher level of productivity that would come with it. And so then you can see in that case, in a low to moderate digging resistance application, the higher rated payload of 54.4 metric tons gives you more than you need to do that. So there's some gray area, and this is where I'm going to introduce the idea of let's collaborate on this and figure out what the right payload is for this machine for the job that you need it to do. So there is potential to get beyond that 4-pass match using the 785, for example, but then you've got to get it all the way up to that 45.4 or 50 U.S. ton payload. Now, stretching just to one other example on the other extreme, the picture on the lower right-hand corner, that's a 994K loading a Cat 797. So we've gone all the way up onto the largest size class here that a 994 has been, that we've seen 994s loading in the field. And in this example, again, you can do an 8, 9, or 10 pass match. And the key is to look at those target payloads and where the rated payload is at. If you're coming down from the rated payload, it's a pretty easy scenario, but then sometimes we can also go up a bit from the rated payload. On the next slide, I'm going to show you a tool in this same publication that I was talking about, internet searching, that can help you make these calculations on getting an exact match between your wheel loader and the truck. So I'm going to show you two different tables. First table here is in what's shortened to the name of a face application. So this is otherwise known as moderate to high digging resistance. We understand that the blast from one mine to another or one quarry to another can vary. In some cases, the material is very free flowing. Even in a face application. In other cases, it's pretty tough digging, and it depends on many variables, how the material is interlocked, the size of the pieces after the blasting, the size of the blast size. So first of all, we have the face application. That's the rated payload that we've seen all along since this machine was introduced a number of years ago. Moving into what's new, we now have in this publication the higher payload for the what's labeled here as a loose rehandled application. Defining loose, what that really means is low to moderate digging resistance, and that's where we can collaborate with you using videos and cycle time and to understand exactly what digging conditions you have so that we can figure out, do we need to be all the way to can we go all the way to the upper end, to the top of the new rated payload in this application, or does it make sense to be kind of halfway in between the face and the loose rated payloads? So the key information that's in this table is the maximum swung load in the machine. And in a nutshell, what that means is you can now look at the maximum capability and subtract the bucket weight. That'll give you your maximum payload. This table uses an example of preset example bucket weights. Any bucket, configuration can be different. So the key is to understand that you can start backwards from your maximum capability, figure out what your maximum payload is after subtracting the bucket weight, and then you can go from there and assess your site's variability and decide, where should my target payload be? Can I cut it close and be within a few percent of the maximum payload? Or am I expecting a lot of variability, so therefore I want to set my target payload 10% below the maximum in this particular configuration? So let's work together to optimize the 994K for your application. The picture I'm showing here is the end of this document that I've been referencing, this PEDJ0482 document that you can find by internet search. So please take a look at that and let us know how we can help to have you be able to optimize the 994K to your application. That's all for the 994K. Now let's watch a quick video, and then we'll take a look at an all-new large wheel loader model that will be available soon. hope you enjoyed that video. So that's the new 992, the new Cat 992 wheel loader. And this is a very capable machine, and you'll see some details why very soon here. So here's a quick overview of what's new on this machine, what it's all about. We have a higher rated payload, starting with the payload of 25.5 U.S. tons or 23.1 metric tons in a typical quarry face or mining face type application for the standard lift, and 22.5 tons or 20.4 metric tons on the high lift application. Now, what's also new for this machine is a material handler variant, and that's where you've got typically rehandled material, where now we're going to be able to add some stability to the machine and have a package that brings you to 30 U.S. tons, standard lift 27.2 metric tons, or 27 tons on the high lift, 24.5 metric tons. Looking at these numbers on the bottom, the numbers that you're seeing here came from a production study that we ran on our field follow program. And what we've demonstrated is that this machine can be up to 32% more productive than the 992K, up to 48% more efficient than the 992K. And then also on top of that, less maintenance cost. And then over on the right-hand side, you'll see a list of some technology features that are related to empowering operators, adding to operator confidence, and I'll have some more details for you on those too. So I think this is a fun picture. This is a pretty exciting thing that we have been able to increase the capability of the machine, but as you can see on the picture, we haven't grown it outside of its size envelope. The 992K is shown in the black shadow, and the new machine is pretty much the backside entirely within. And so you can see we put more capability in, but we haven't grown the size. So if you have an application where the 992K worked, the 992 will fit right in and do the job even better. The first thing I'll talk about is productivity, what we've done to increase the production capability of the 992. So first of all, increase in rim pull and breakout force combined with an optimized Z-bar linkage means faster dig times, even with a larger bucket and a higher payload. Now the payload increase is all about pass match, as we discussed earlier in the production calculation when we were talking 994K and how that relates to the pass match to the truck. So we'll move on to that. I do want to highlight the material handler payloads. That's a similar situation to what we've done with the increased rated payload on the 994. In this case, it's actually a different machine configuration with extra counterweight, just to compare what we're talking about now versus the 994K, where the machine is actually the same machine doing two different jobs. What we did here with the payload really revolved all around 4-pass match to the 777 truck in all applications. Now on this slide, I'll go back to the math one more time, and I just want to focus on when you're moving from 5 to 4 passes. If you had an equal cycle time, working out the math, you would expect a 25% increase in productivity going from 5 to 4 passes. Now, in the production study I mentioned, we actually did better than that. We had an improved cycle time that got us to 32% increase in productivity versus the 992K in the same application on the same day doing the same job. Now here, let's focus on what happens if you're already in a situation where the 992K is doing a 4-pass match. They're not doing that 5 to 4-pass switch. In this case, you can expect a 15% increase in productivity. What happens is you now have the same size bucket you've always been running. So instead of an equal cycle time with a larger bucket, now you've got a faster cycle time with the same size bucket, and that's expected to get around a 15% increase in productivity. Moving on to efficiency. So first of all, starting with what we've demonstrated on efficiency, the numbers are really, really impressive here. We've seen a 48% increase in efficiency measured in payload per fuel, so tons per hour, for example, demonstrated versus the 992K in a production study. That was with the 992K 5-pass loading and the 992 4-pass loading. At the same time, we have, on a different site in the world, we measured a 21% increase in efficiency in the scenario where it's an equal pass match. This was, in this case, 992 versus 992K. They were both loading rail cars, but where they were limited to where they couldn't do one last pass. And so in an equal pass match situation, a 21% increase in efficiency is some demonstrated gain that you can expect to use as guidance. So let's talk about the optimized Z-bar linkage. This is a key enabler to the efficiency. We have people who have asked, you kind of perfected the monoboom. It's been doing good in the field. And so after the success of the 992K, why are we changing? And the answer is we wanted to get to the next level of efficiency, not only productivity, but efficiency. And in order to achieve that breakthrough, we really needed to start with, we'd start over with a brand new linkage design, optimize the design, and went through millions of iterations and on our computers, and we were able to use this multidisciplinary design optimization to come up with a linkage that really is competent at what it does, and it really enables that next level of efficiency. And along with that, going to a Z-bar linkage that also allowed us to go back to standard grease pins for ease of service. Another thing that actually makes a measurable difference in efficiency is the bucket. So we moved a performance series bucket. There's some details here that I won't talk entirely through, but I just want to bring your attention to our focus on the bucket design and the productivity and efficiency advantage that you get with the proportions and the design of a cat bucket, besides the fact that we have our machine level loads that we can use to analyze the bucket in order to optimize the weight, optimize the performance, and therefore optimize the durability and the value over the long run. I wanted to bring some specifics on what other features of the machine are enabling efficiency, because it's a big number. So I'm guessing that there may be questions. How did you do that? So first of all, on top of the features, on top of the basic features that gave us the numbers in the production study that I talked about, we also have some optional technology, dig assist and operator coaching, that will enable the forces in motion of the machine to be used for useful work rather than waste heat or wear and tear on the machine. So that brings you to an additional gain in efficiency on top of what we demonstrated in the production study. The production study numbers that I referred to did not depend on this technology. It hadn't been turned on yet on the machine. All-around variable displacement pumps for implement, for steering, and for the cooling fan. The standard operating mode of this machine is what we're now calling on-demand throttle. That optimizes the efficiency and the power, the power and the speed of the engine throughout the digging cycle, so that you can improve efficiency but without slowing down your production. So that's a nice feature that is just a standard operating mode of the machine. For situations where you temporarily need more power, there's now going to be a horsepower plus mode. The engine power management optimization that was performed by the engineering teams so that there's a good balance between implement and propulsion is also a key enabler. There's engine idle shutdown feature. There was a torque converter optimization, engineering optimization done on this machine, on this new design, and a new pump drive ratio was another contributor. So I'll go into a few details on the three different optional technologies that have been demonstrated to benefit both new and experienced operators in the field. We've gotten some really positive feedback on these optional technologies. As I mentioned, the efficiency numbers that we talked about in the production study did not depend on these technologies, but at the same time, these features can help a larger group of operators to actually demonstrate the full efficiency potential of the machine. So with our assist features, operator assist, there's three elements. The top two that you can see on the slide both relate to managing tire slip but also optimizing the rim pull into the pile. So starting with the tire slip prevention, what this does is it actually reduces the rim pull before the tires are set, and then increases the rim pull when downward force is applied to the tire. So what that means is it's preventing the tire slip before it happens. It's a proactive rather than a reactive solution. So what you get there is when the machine when the traction is there, you get more rim pull. When the traction is not there, you get less. So that not only gets you improved tire life, but it also gets you better digging performance, moving faster through the pile, which helps productivity. Now, also related to the idea of not spinning the tires this is my favorite feature, the tire set element of Dig Assist. So this is a hard part of the digging cycle for an operator to manage. It's really hard to be able to tell by a seat of the pants feel when you're operating the machine exactly at what point the bucket is far enough into the pile where you can use your lift command and therefore pin the tires and add that extra traction to the front tires. And so this is an element I've been calling it partial autonomy. So what the machine does, it automatically applies the lift command at exactly the right time so that you get that available traction. And then once the machine detects that traction and it measures that force, then that works together in conjunction with the tire slip prevention to go ahead and increase the rim pull so that you have that improved penetration into the pile. Now, once you're into the dig and you're halfway through the dig cycle, the lift arms on any wheel loader and the wheels, they kind of fight each other. The pile's trying to push the lift arms back down. Your hydraulics are trying to lift, and that balance is key. And so if you're pushing too hard in the pile, that can stall your lift function, hydraulically stall. And what the Dig Assist feature does is it watches for that, and right as that is about to occur, it will automatically apply the impeller clutch, meaning that it will automatically reduce the rim pull. And what that does is it keeps your lift arm moving through the pile before it stops. Another optional feature now is payload overload prevention, and that's an optional package that includes both the CAT payload and the payload overload prevention in one package. The key to the payload overload prevention, it was developed to increase the productivity and efficiency, not to decrease. So an intuitive, first glance at the idea of limiting your payload seems like it would slow down production, but really what it does is in situations where you have varying density and you might want to put a little bit larger of a bucket, what this does is it provides you confidence to use that larger bucket without the risk of overload. And so now you can have a situation where you can have varying density and, for example, be consistently forepassing a truck by using a little bit larger of a bucket, rather than having to drop down to 5 pass when you go into the lower density, and all without introducing the risk of overloading the machine. I also want to highlight the accuracy of our CAT payload. We were able in our production study to measure 60 truckloads going across in-ground scales, and the CAT payload feature looking across all of the measurements was within 1.1% of the in-ground scale. So we've achieved really good accuracy with the CAT payload, so that you can keep a nice tight tolerance on the actual payload that goes into your truck. Operator coaching is another significant feature here, and I'll show you an example of a coaching tip on the next slide, but for now, this is a list of all the things that the coaching feature is going to be watching. And the idea here is this gives the operator some self-help types of videos that they can watch. So just to give one example, this coaching tip, that what you're seeing here is it identifies whether or not you need help on a particular aspect of your technique, points out which ones where improvement is suggested, and then it gives you how-to videos that show here's what's not to do, and then here's the right way to approach this part of the digging cycle. And this can help. Using a proper operating technique helps productivity, it helps efficiency, and then it also even can increase the expected durability of the machine. Okay, moving on to operator comfort and safety going into the cab. So first of all, take a look in this picture at the space, the visibility, and the access to information. The operators have been really thrilled so far at the comfort and the access of information of this cab, the ergonomics. And this is important because a comfortable operator is also therefore then a productive and efficient operator. There's 2 cab options. The deluxe seat is now standard, so the only difference between the 2 cab options is in the glass. You can have the zip-in glass for faster replacement time in the event of a crack, or you can have the bonded glass, which is what's shown in this picture, which just has this bonded seam on the two junction between the 3 panes of glass. Here's a little bit more detail on the increased the leg room. The next generation seat has some really nice enhancements too. The active heating and active cooling and heating, adjustable lumbar support, and seat cushion tilt adjustment, to name a few. Another important thing I want to point out is the increased. It's not just increased leg room fore aft. There's also increased room. Kind of in the area of the operator's needs, so increased width for your knee placement. One more detail I want to point out revolves around the trainer seat. So there's a larger trainer seat, and then there's also an optional suspended trainer seat in this new cab. Here's a few different views of the easily accessible information, and one thing I want to point out here that I think is really handy is the electronic version of the operation and maintenance manual shown in the lower left-hand corner. So you can now get to the entire operation and maintenance manual through the onboard display on the machine. Job aids are another new feature that I expect to be pretty useful. So the feature shown here on the bottom of this screen with the picture of the bucket and the -3 degrees is the tilt angle. So there's a few different job aids that you can toggle through, but this, for example, you can use to make sure that your detents are set correctly, or when you're not using them, to help you maintain good floor conditions. Moving on to the vision and the object detection, there's a few options here. So the rear view camera is still standard. The radar object detection is going to be an option, and then also a 270-degree vision option that gets you, if you look in the upper right-hand corner of this display, it gets you two side cameras that show you what's going on down in the articulation hitch area of the machine. Now, this screen that we're looking at here is mounted up on the windshield pillar, where going back to that first slide that I showed. Let's talk a bit about serviceability. So on the topic of serviceability, first couple of things to point out. We're consistent now with an 854K or 994K or 993K with the walk-around access to the windshield, and then also improved access to the radiators to clean out your cooling package. What's new here, the service center moved to the left-hand side. All the capabilities on the 992K have been carried forward. The fluid drain and refills, the fluid level indications, but the key feature here of what's new is that we've moved that to the left-hand side, so it's in a preferred location, right where the operator and the maintenance technician needs it to be. Another detail I'll point out here on the topic of serviceability, the pump bay in this example in the upper right-hand corner maintains excellent access to the hydraulic pumps. Moving on to durability, let's start with the powertrain. So on the topic of durability, the key number here is this 18,000 hour planned component replacement interval. So we've aligned engine, transmission, final drive axles, all to that same number, this 18,000 hours. And I'll talk just a bit about what enabled this. What you're seeing on the right-hand side is what's new. So the axle housing size has increased. We've used a larger bevel set. There's been an increase in the oscillation joint diameter. Going down in the drop box, we have an increased hardness on the output transfer gears. And then to the engine, the increase in the engine replacement interval to the 18,000 hour mark is made possible by improved durability of the C32 engine that will be standard starting with the introduction of the new 992. The front frame, this is an all-around solid design. Just a couple of things to point out. If you look at the way that that front end is closed in, that does a nice job to create torsional rigidity. And looking up at the castings at the top, the engineers on this frame did a nice job managing that load path. The rear frame has some substantial improvements. One thing that I want to point out is the trunnion mount. So that's number 2 pointing to the trunnion mount. That's where the axle bolts up into the frame. And what's significant here is we're now centered directly underneath the rail. So that really improves the load path with the bolted joint being mounted directly underneath the rail. Okay, last item on durability that I want to highlight. In some applications where you have a load and carry situation on grade, we've got a new feature that can help you extend your brake life. So this is the optional advanced automatic retarding controls with engine brake. The key here is this allows you to fully control the machine speed on grade without any input from the operator. So it uses a combination of the compression brake on the engine, the engine braking, along with the gearing of the transmission and the implement and fan pump to hold that speed without any input from the operator. Now, even the standard option here with the standard automatic retarding controls provides some key features here. It disables the impeller clutch and enables the lockup clutch, and then it also uses your implement and fan pump retarding to slow the machine on grade. The key here is the downhill cruise control in this mode will hold the machine at the constant speed as long as it has the capability to do so. However, the operator does still need to monitor, and if the machine exceeds the desired speed, then the operator will then have to apply the service brakes. Let's take a quick look at the specs comparison. So starting with standard lift machine, I'm not going to go through all these specs, but I do want to highlight one thing. Let's just take a look at the static tipping loads. So, and just at the percentages. So we'll take the static tipping load, 40 degrees articulation, and just to compare back to the 992K, you can see that we have a 15% improvement in stability with the standard configuration, and then the material handler, that extra counterweight, makes the machine 21% more stable. So this is a nice way to just make a direct apples to apples comparison on, I showed you earlier, it's within the same size envelope. You might wonder, well, what real stability did it gain? These are the numbers. Now moving to high lift, we've got a 12% increase in tipping load versus the 992K in the face configuration, and in the material handler configuration is 17%. Now, just to bring the Imperial units into the picture, percentages are the same, so I won't highlight that again, but I just wanted to be able to show these spec slides for your reference. So here's the standard lift specs and ending with the high lift spec comparison. Thanks for your time today. I hope you found this information helpful. Please check out the resource list on the left side of your screen for more information. And now on to the Q&A.